One of the hardest things for students to do is to solve equations that have fractions in them. So I'm going to show you an easy way to get rid of fractions in an equation. Okay, and an equation is the key word there. All right, so let's look at example 1. We have x divided by 4 plus 5x divided by 3 equals 10. When you're trying to get rid of those fractions in your problem, look at your denominators. You have 4 and 3 as your denominator. And you want to think of what is the smallest number that 4 and 3 both divide into evenly. So we think, 4 and 3, 12. So 12 is known as our least common denominator. So what we're going to do is multiply every single term by 12. Because remember, this is an equation. The left side and the right side are balanced. So whatever we do to the left side, we have to do to the right side. So I'm going to multiply every term in the left side by 12. And I'm also going to multiply every term on the right side by 12. All right, so let's think about reducing these fractions. Remember, 12 is like 12 over 1. So we think 4 goes into 12 3 times. So this is going to reduce out. So 3 times x is 3x. Notice no fraction. Plus, this 3 goes into 12 4 times. So this reduces to 4. And 4 times 5x is 20x. Equals. Now there's nothing to cancel out here, so we just multiply 12 times 10, which is 120. Now notice we have an equation that doesn't have any fractions in it. So we can combine 3x and 20x makes 23x. And now we're just going to divide both sides by 23. (120) over 23 does not reduce. You always want to see if a fraction will reduce or not. This one won't, so this is our final answer. You can always put that back in place of x in your calculator and check to make sure that this is true. All right, now let's get to one that's a little bit more difficult. This time we have x plus 3, x minus 3, and x squared minus 9 as our denominators. Now, anytime that you have a polynomial in the denominator, you always want to make sure that it's factored out completely. The x squared minus 9 is known as a difference of squares. This is really x plus 3 times x minus 3. So it's really the product of those two. So when you're trying to think what is the least common denominator of x plus 3, x minus 3, and then the product x plus 3 times x minus 3, it's going to be this product right here. So our least common denominator is x plus 3 times x minus 3. So we're going to multiply every single term by that least common denominator. So we're going to have x plus 3 times x minus 3 times this 1 over x plus 3 minus, because there's a minus there, x plus 3 times x minus 3 times 6 over x minus 3 equals, and then again, x plus 3 times x minus 3 times the 14 over, and instead of writing x squared minus 9, I'm going to write it as x plus 3 times x minus 3. Okay, so when we look at this first one, notice we have x plus 3 and x minus 3. They're both whole numbers, so it's like they're sitting over a 1. So the x plus 3 and this x plus 3 are going to cancel out completely. And we're left with x minus 3 times this 1 minus, here the x minus 3's are going to reduce out. So we cancel those, and that's going to be an x plus 3 times the 6 that's left over equals, Here, the x plus 3's cancel, and also the x minus 3's cancel. So notice this just becomes 1. 1 times 14 stays 14. No fractions. Okay, now let's simplify this. We're going to have x minus 3. Now, when we subtract this, think about this is 6 times x, and we're subtracting it, so we have minus 6x. And we have 6 times 3 is 18, but we're subtracting, so it'll be minus 18 equals 14. All right, we're going to put our x's together. 1x minus 6x is negative 5x. A negative 3 and a negative 18 makes negative 21 equals 14. We're going to add 21 to both sides. So 14 and 21 makes what, 35? And then divide by negative 5 on both sides. So x equals negative 7. So x equals negative 7 is our solution. And we also want to make sure that you see that in your denominator, we could not have a negative 3 here as a solution because that would make the denominator 0. We could not have a positive 3 as a solution because that would make the fraction undefined again. And of course here, x couldn't be negative 3 or positive 3. All right, now this third one, we could multiply through by the least common denominator. Notice we have 2 different denominators. It would be 3 times 5x plus 4. So we can multiply both sides by that, or look at it specifically. When you have one fraction equals another fraction, this is called a proportion. And if you multiply by 3 times 5x plus 4, it's the same thing as if you just cross multiply. So we're going to wind up multiplying 3 times this 5x minus 4 equals, and then 2 times the 5x plus 4. The other problems, we didn't just have one fraction equals another fraction. But anytime you have that, it's called a proportion, and just cross multiply. It gives you the same thing as if you do this. All right, now let's simplify. We get 15x minus 12, because I distributed my 3, equals 10x plus 8. Now, I need to solve for x, and I have more x's on the left than I do on the right. So I'm going to take away 10x from both sides, so subtract 10x. Try to get x by itself. We're going to add 12. And then divide by 5. And notice if we put 4 in place of this x, the denominator doesn't become 0. So we're good on that. X equals 4 is our solution. So that's how you get rid of denominators in your equations. So to get rid of those rational equations, just multiply through by the least common denominator. Gets it out of fraction form every time.